Infinity has long been an idea surrounded with mystery and confusion. It is defined as a number greater than any assignable quantity or countable number. A man who changed what mathematicians thought about infinity in a series of what were radical ideas was Georg Cantor. One of these was the idea that there are infinities whose values are greater than other infinities. This is what we are going to investigate further. This can be demonstrated by Cantor's proof that the infinity for real numbers is greater than the infinity for natural numbers. In terms of definitions, natural numbers are defined as the counting numbers, which have no decimal representation, examples of which include 1, 4, and 10. Conversely, real numbers are numbers that have finite or infinite decimal representation, examples of which include 1.5 or 1.66666. Our first important concept to learn to understand Cantor's proof is one-to-one correspondence. Since it is impossible to count all the values in an infinite set, Cantor matched numbers in one set to a value in another set. The one set with values still left over was the greater set. Another concept we will need to utilize is proof by contradiction. Proof by contradiction is a popular method in mathematics. Instead of directly proving that something is true, it shows that it is impossible for it not to be true. We pretend for a while that the proposition we want to prove is false and deduce that this would result in some impossibility. We are now ready to face Cantor's diagonal method, which is a type of proof by contradiction and involves one-to-one correspondence. We want to prove that there are more real numbers between 0 and 1 than there are all natural numbers. So let's pretend the opposite proposition is true instead. There are as many real numbers between 0 and 1 as there are all natural numbers. If that is true, it must be possible to list the real numbers in an endless table and number them by natural numbers, as shown in this table here. We are going to arrive at a contradiction of this proposition by constructing a real number between 0 and 1, which is not in the table. Creating such a number is not difficult. Let's call it x. For our number x could start with 0.452153. It differs from each of the first four numbers in at least one decimal place. If we go through all the infinite table in this manner, we end up with an x that cannot be in the table. Thus our original proposition must be false. That means there are more real numbers between 0 and 1 than there are all natural numbers. This implies that the infinity of real numbers is greater than the infinity of natural numbers. And this is an important conclusion, as it already implies implicitly that there is greater than one value for infinity. And this is crucial as it is different to the idea of infinity that we typically have and makes us consider intrinsically what infinity is.